Hey everyone, we are here to start section 5.3, which is all about conditional probability and independence. This is our final section of chapter 5 on probability. There's going to be at least 3 videos for this section. They're not going to be super long, but I just want to make sure you can refer back to specific videos if there's certain topics you want to revisit. In our first, let's talk about overall. After this whole section, so not just this video, but this whole section, we're going to do a couple things, right? We're going to be able to define conditional probability. We're going to be able to actually compute conditional probabilities, right? Those are going to be our 2 main goals for this video. We're going to talk about how you describe chance behavior with tree diagrams. We're going to define independent events. We're going to determine whether or not 2 events are, in fact, independent. And then we're going to do lots of practice where we just apply a general multiplication rule to solve probability questions. So, this video is all about conditional probability. Now, what is conditional probability? When we are trying to find the probability that one event will happen under the condition that some other event is already known to have occurred, that's when we're trying to determine a conditional probability, right? Back in chapter 1, we looked at conditional distributions. This is basically the same thing, but without having to make the bar graphs for it. The probability that one event happens, given that another event is already known to have happened, is called a conditional probability. So there's our definition, okay? So suppose we know that event A has happened. Then the probability that event B happens, given that event A has happened, is denoted by by the probability of B given A as written here. Okay, so this little line, it's just a straight up and down line. It's read given that, or under the condition that. All right, we're going to go through a bunch of examples, okay? So this example, comes from a university, and we're looking at the grades that we've received. And so we can see that we have the different schools within the university printed here, and then the grade level is up here. So this is our 2-way table, okay? Now, what we're going to need to do to find these probabilities, right? We're assuming that we're letting E represent the event that the grade comes from an engineering and physical sciences course, and then we're letting event L represent the grade is lower than a B, okay? This 2-way table does not show us the totals, right, for the margins. So the first thing we want to do is we want to find all of those totals, right? Because when you're doing probability, your denominator is going to be one of those totals, right? Whether it be a row total, a column total, or a grand total, we need to have that filled in. So if you ever get a 2-way table that doesn't have those already provided, you're going to want to go ahead and add them. Okay, so let's go through our first one. We want to find the probability that a grade is lower than B. So there were 3,656 out of 10,000 students, or grades, reports, that were lower than a B. So about 0.3656 is our answer for that. So you needed both of those totals as your answer. Now, the next one. Find the probability that it was event E, given that event L already happened. So what's the probability that a grade comes from an engineering and physical sciences course, given that the grade is in fact lower than a B? So that's saying, if I were to have chosen a student or a grade that's lower than a B, what's the chance that it came from the engineering and physical sciences? Well, the engineering and physical sciences who are lower than a B are 800 out of all the total B's of 3656. So where those 2 things overlapped, those 2 events overlapped, that would be your numerator, and then your denominator is going to be the total for what was given. Okay? So then our next one, find the probability that the grade is lower than a B, given that the grade comes from an engineering physical sciences course. Okay, so the numerator is still the same because it's still the same place where they overlap, but now your total, who you're looking at, is different. We're focusing just on the engineering and physical sciences. So that's now my denominator. Notice how these are all three different answers because they're all three describing different events and their probabilities. All right, let's look at another one. Pierced ears versus gender. So it looks like we gathered data from 178 people, and we asked their gender, assuming male or female, and then asked them whether or not they had pierced ears, yes or no. If you're feeling up to it, how about you press pause right now and see if you can calculate these probabilities, and then press play and you can see the answers. Now these are all conditional probabilities, right? I can tell that because it's something given something. Whatever is given is the second thing, and that's the total or the column or the row that you're focusing on. So for this first one, probability, it's yes given male. So out of all of the males, how many of them said yes? So that'd be 19 out of 90. Or for 2, focusing on just the females and those that said no of those groups. And then for 3, of those that said yes, those that were female. So those are my answers there. You can leave your answer as a fraction, or you can put your answer in decimal form. It does not matter. If you're going to do it in decimal, make sure you're including enough decimal places after the 0. I would do a minimum of 3, even 4 to be safe. All right, next example. Who reads the newspaper? Residents of a large apartment complex can be classified based on the events A, they read the USA Today, and B, reads the New York Times. So the question we're asking, what is the probability that a randomly selected resident who reads USA Today also reads the New York Times? This is a conditional probability question, okay? It's not written, so if I go back, it's not written all nice and cute like this. It's, a sentence question. So you have to be very careful with then how you interpret what are they asking is given. What are we trying to assume here? What are we looking for? So it says, what is the probability that the randomly selected resident who reads USA Today? That's your given. So given that they read the USA Today, what's the probability that they also read the New York Times? So if we wanted to write this as like probabilities, A's and B's and things like that, we want to know what's the probability of B given A. What's the probability of B given A? Now, this two-way table is interesting because it includes both counts and percentages. You can calculate it either way. So if this table had just been showing you proportions, I should say, you can use that in your calculations. Or you could have used counts, either or, depending on what's given. So in this case, the probability that someone reads the New York Times, given that they also read USA Today, is going to be 0.125. So writing your answer out so someone can understand it, there's a 12.5% chance that a randomly selected resident who reads USA Today also reads the New York Times. Something else I wanted to point out about this example, how you can see the Venn diagram relates to the two-way table. Notice how where it's 2 yeses overlapped, that's where the 2 things overlapped. If there were 25% of people read the New York Times, then the New York Times event bubble has to sum to 25. So 20, only read New York Times but not USA Today. And then same thing for, did I do that right? Yes, same thing for USA Today. 40% for USA Today, but only 35 do USA Today, but not New York Times. And then 40% read neither. So there's that. In your Venn diagram, though, you don't see your answer of 0.125. That's not there. All right, again, how about you press pause on this one and see if you can calculate these 2 conditional probabilities. This data is talking about whether somebody is a homeowner or not, and then whether they graduated from high school or not. So press pause and see if you can calculate these 2 examples. to be a homeowner given that you're already a high school graduate, that'd be 221 out of 310. Given that you're a homeowner, what's the probability that you're a graduate? So what's the probability you're a graduate given you're a homeowner? Again, 221, but now it's out of 340 as opposed to 310. So for conditional probabilities, we're never using this grand total. We're always using either a row total or a column total, depending on which condition we're focusing on. In the next video, you're going to be looking at conditional probability and independence, how they relate to each other. And then we're going to tie it back in and talk about independent events and mutually exclusive events, if they're connected or not, how you can tell one from the other, and so on. Okay? All right, stay tuned for the next video.